We've built a neuron, stacked neurons into layers, and given them activations. Now let's actually run one. Forward propagation is the act of pushing a single example through the whole network, one layer at a time, until a prediction pops out the other end. We'll compute every single number by hand. Here's our tiny network. 2 inputs on the left, 2 neurons in a hidden layer, and 1 output neuron on the right. Our example is simple. The first input is 1, the second is 2. Watch how these 2 numbers travel all the way across. Start with the top hidden neuron. It does exactly what one neuron does. Multiply each input by its weight, and add them up. 1 times 0.5 gives 0.5. 2 times 0.8 gives 1.6. Add the bias of 0.1. The running total climbs to 2.2. That's this neuron Z. The bottom hidden neuron works the same way, but with its own weights. 1 times minus 0.6 is minus 0.6. 2 times 0.3 is 0.6. Add its bias of minus 0.2. Those cancel out and the total lands on minus 0.2. 2 inputs, 2 hidden neurons, 2 Z values, computed, not guessed. Each Z now passes through the hidden layers activation. Here, the tanh function, an S-curve that squashes values into the range -1 to 1. Feed 2.2 through the curve and it comes out at about 0.98. Feed minus 0.2 through, and it comes out at about minus 0.20. Those 2 squashed numbers are what the hidden layer passes forward. Now the output neuron combines those 2 hidden values, again with weights and a bias. 0.98 times 0.7 is about 0.68. Minus 0.20 times minus 0.9 is about 0.18. Add the bias of 0.4. The running total comes to 1.26. That's the output Z. One last step, push that Z through the output activation, a sigmoid, to squash it into the range 0 to 1. Find 1.26 along the bottom, go up to the curve, and read across. The output counts up to 0.78. That single number is the network's prediction for this example. So what does 0.78 mean? Because the sigmoid output lives between 0 and 1, we read it as a probability. The network is about 78% confident this example belongs to the positive class. Not certain, but leaning clearly toward yes. Notice the whole journey went one way. Inputs, to hidden layer, to output. Left to right, never backward. That single left to right pass is what we call forward propagation. And under the hood, every layer is just a weighted sum followed by an activation, the exact neuron we built, repeated. In PyTorch, this entire pass is a single call. You hand the network your input, and calling the model runs every layer for you. Out comes the same 0.78 we just worked out by hand, proof that the framework is doing exactly the arithmetic we traced. To recap forward propagation, each layer takes the values before it, forms a weighted sum, and applies an activation. Those values flow input, to hidden, to output, and the final squash number is the prediction. But is 0.78 a good prediction? To know, we need to measure how wrong it is. That's the loss function, coming up next.